Okay guys, so 3.2, we are simplifying expressions involving powers, and that includes negative exponents. So I'm going to give you all of your exponent rules first, and then we'll look at examples. So your first exponent rule is when we are multiplying powers. Now all of these rules are given to in general terms. We'll actually do examples with them after I give you all the rules, okay? So the exponents m and n will actually be numbers. So when we are multiplying powers, I have a to the power of m times a to the power of n. When you have that, you are going to be adding exponents. So your answer will be a to the m plus n. Now, division is the opposite of multiplication, so when you're dividing at powers, what do you think you're going to do? Subtract. And your answer always ends up in either the numerator or the denominator where your exponent was larger, okay, when you're subtracting exponents. But we'll look at an example. When you have a power raised to a power, so you have an exponent inside parentheses, and then there's an exponent attached to that parentheses, you multiply the exponents together. So you're not adding them. In that case, you are multiplying them. So we also have inside a power of power, if you have multiple bases raised to that power, you can do what I call distributing the exponents. So if you have inside of a parentheses 2 bases, and it's raised to a power, you take that power and you raise both the bases to the power. Now I want to make it very clear here. The exponent stays an exponent the whole time. You are not multiplying the exponent times the base, okay? You are still multiplying powers only. This gets confusing when your base is a number. So you are still always raising the base to a power. You are never multiplying your exponent times the base. Same idea if there's a fraction inside the parentheses. You distribute that exponent to the denominator and the numerator. But it stays a power every time. If I have a negative exponent, I like to look at this as paying your rent. If you don't pay your rent, guys, what happens? You get kicked out. So a negative exponent is kind of like not paying your rent. This guy, a to the negative m, the negative means he didn't pay his rent. So he got kicked out of the upstairs apartment and he had to move somewhere else downstairs. So you will move anything with a negative exponent to either the numerator or the denominator depending on where it is. Same thing with this other example. If you have 1 over a to the negative m, that negative means he gets kicked out, so he has to move upstairs. So after you move your exponent to the opposite location, it becomes positive because now he doesn't owe anything anymore. Okay? It's kind of like a big sign saying I'm in the wrong place. So after you move the negative exponent, it is now in the right place, so it becomes positive. Okay? Last rule is what happens when you have a 0 exponent, and that one's easy. Anything to the power of 0 is equal to 1. So example 1. Your instructions for any type of exponent problem will be to simplify, and that means that you want to leave no negative exponents in the answer. So you always want your exponents to be positive. If you have a negative exponent, then you are not simplified. And then you always also want to make sure that you only have one of each variable or one of each base present in your answer. So let's take a look at example 1. Now the biggest thing when you're multiplying exponents is that you can only multiply a base by another base that's the same. So it's like combining like terms, okay? So we can only multiply bases that are the same. So let's take a look at what we have. 2ab squared times negative 4a to the third b to the third c. In this example, I have two coefficients. You can multiply coefficients because they don't have exponents to them. So what is a 2 times negative 4 going to give me? Negative 8. Now let's multiply the a's. I have a and a to the third. If I have just a by itself, that's actually a to the what? To the first. So I'm going to write it out this way just once so you guys have it written, the work. This is going to be a to the first plus 3 because we're multiplying, so you add the exponents. And then let's do the b's. That's b to the second and b to the third. So that's going to be b to the 2 plus 3. And then c is just hanging out all on its own. So when I simplify, this is going to be negative 8, a to the 4th, b to the 5th, c. So example 2, I have x to the 11th over x to the 5th. So this is division, so what am I going to do with my exponents? Subtract. And remember, your answer always ends up where the bigger exponent is. Which one's bigger here? X to the 11th or x to the 5th? X to the 11th. So all my x's are going to end up on top. So this is going to be x to the 11 minus 5. And what's 11 minus 5 give me? X to the 6. Okay, so example 3, we have y to the 20th over y to the power of 30. I'm still going to be subtracting my exponents, but where are my answers going to end up? On the bottom, because 30 is a larger exponent. So this is actually going to be, in the denominator, y to the what? Positive 10, because we're just doing that at the beginning. If there's nothing in the numerator, what do I have to put? A 1. So because y to the 30th is larger, your answer ends up in the denominator. So you just put a 1 in the numerator. Why does this work? If we use our rule from before, that's going to give me y to the 20 minus 30, yes? And what's 20 minus 30? Negative 10. So in my numerator, I would have y to the negative 10. So what does that mean I have to do with that negative exponent? Bring it down. So that would be a 1 in the numerator and a y to the 10th in the denominator. Same thing. So example 4, we have 1/3 to the negative 5th power times 2/3 to the 4th power. What I would do here is I would first get rid of those exponents. So we're going to distribute the exponents to each one. Now remember, this is not multiplication. It is still an exponent. So when I rewrite this, it's actually going to be 1 to the negative 5th power over 3 to the negative 5th power times 2 to the 4th power over 3 to the 4th power. When we multiply fractions, we multiply straight across, but our bases aren't the same in the numerator, so we leave them separate. So this is going to be 1 to the negative 5th times 2 to the 4th over. In the denominator, my bases are the same, so what can I do with those exponents? You can add them. So what's 3 to the negative 5th times 3 to the 4th? 3 to the negative 1. Now, we are not simplified. Why? You can finish, you can do all of the powers, but we also have some negative exponents, right? So first, let's get rid of the negative exponents. You only move the negative ones. So we're going to move 1 to the negative 5 and 3 to the negative 1. So that gives me 2 to the 4th times 3 to the first over 1 to the 5th. Can we do this, guys? Yeah. What's 2 to the 4th? 16. Times, what's 3 to the 1st? 3. All over 1. And 16 times 3 gives me 48. So example 5. We have 5 to the 2nd times 5 to the 0 times 5 to the negative 4th. What do you guys notice about this problem? There's a negative. What else? There's a 0. What about the bases? They're all the same. So we can multiply these, right? What would we end up doing with the exponents? Adding them. So this is 2 plus 0 plus negative 4. So that would actually be minus 4. So that's going to give me 5 to the what? Negative 2. Now, is this simplified all of the way? No, because there's a negative exponent. So what I do is I put the whole thing over 1, and then I'm going to move that negative. Question? Okay. What? Say it again, if you were to. Yes. Mm-hmm. Yeah. Okay. So that gives me 1 over 5 squared. And what's 5 squared, guys? 25. Mm-hmm. Example 6. 3x to the 5th y over negative 6x to the 6th y to the 3rd. All of that to the negative 2nd power. Here's what I would do. I don't really want to deal with that negative exponent just yet. Let's simplify inside the parentheses first. Okay? So let's take a look at our coefficients. We have 3 over negative 6. How does that simplify? 1 over negative 2. Good. Then I have x to the 5th over x to the 6th. Where will my x's end up? Top or bottom? And how many of them? Just 1. Then I have y over y to the 3rd. Will they end up at the top or the bottom? Bottom. And how many? 2. So that's going to be y squared. All of that to the negative 2 power. And then the last thing that we're going to do is we're going to distribute that exponent of negative 2 to everything. So that gives me 1 to the negative 2 over negative 2 to the negative 2, x to the negative 2, y to the negative 4. Everything here is negative, so we have to actually move the entire denominator up and the entire numerator down. So this is going to give me in the numerator negative 2 squared, x squared, y to the 4th, over 1 squared. So ladies and gentlemen, simplified, that gives me 4x squared, y to the 4th, over 1, so I don't have to write it. So that's your answer. Alright guys, example 7, 4t times s to the negative 1, t to the negative 3, all of that to the negative 2nd power. What would you guys do first? Distribute the negative exponent. Good. So distribute that negative exponent to the parentheses. So that gives me 4t times s to the what? 2nd, t to the 6th. So now I have 4t times s squared t to the 6. So we need to multiply everything that's left over. Is there anything to multiply 4 by? No, so it stays 4. Is there anything to multiply s with? No, so that's s to the 2nd. T to the what? To the 7th. Because this is a t to the 1st power. So when you add the exponents, it gives you 7. Okay, example 8. I have x to the negative 3rd over y squared times 1 over x y. What I would do on this problem is I would take care of my negative exponents first, and then I would just multiply straight across and simplify if I have to. What negative exponent do you guys see? The negative 3. So that x to the negative 3 has to move down. So that's going to leave me with 1 over x to the 3rd, y to the 2nd, times 1 over xy. Now we can just multiply straight across. What's 1 times 1? 1. What's x to the 3rd times x? X to the 4th. And what's y to the 2nd times y? Y to the 3rd. And that's your answer. Example 9. 6c to the 4th, f to the negative 3rd to the negative 1st power, 3c to the negative 3rd, f to the 3rd to the 2nd power. What I want you guys to try right now is distribute the exponent to everything inside the parentheses. Okay, guys, c to the, or we have 6 first, and we are distributing that negative 1 to the base of 6. So you're not multiplying 6 times negative 1. I wanted this to be very clear. This is 6 to the power of negative 1. Now we are multiplying the exponents. So c to the what? Negative 4th. It's a power to a power, so you're multiplying. F to the what? Negative 3 times negative 1 gives me positive 3. Over 3 to the 2nd power. C to the negative 3rd to the 2nd power gives me c to the negative 6th. And f to the 3rd to the 2nd power gives me f to the 6th. So then Carissa asked me a good question. She said, do we simplify now or do we get rid of the negative exponents first? You can do either one. I usually like to make all the exponents positive and then I start simplifying. So which bases with the negative exponents am I going to be moving? 6 to the negative 1 and c to the negative 4th. And what else? C to the negative 6th. Everything else stays the same. So this gives me on top, c to the 6th, f to the 3rd, over 3 squared times 6 to the 1st, c to the 4th, and then f to the 6th stayed the same. Now you're not done because you can only have one of each base in any given place, so we need to actually simplify a little bit more. Let's look at our coefficients first. 3 squared gives me what? 9. And what's 9 times 6? 54. So you have a 54 in the denominator. Now let's look at the c's. I have a c to the 6th in the numerator and a c to the 4th in the denominator. Are my c's going to end up on top or on bottom? On top, and how many? 2 of them, because you're subtracting. And then what about my f's? I have f to the 3rd in the numerator and f to the 6th in the denominator. So where are those going to end up? On bottom, and it's going to be f to the what? f to the third because we subtracted. So your answer is c squared over 54 f to the third.